Hello, everyone. Welcome very much to this show. Thanks for joining us today. I was told this is the first time the Open Infra Days come to Kenya, and this is the first time the Open Infra Days come to Africa. So I'm really excited to be together with you here today and to share a little bit of what we are doing in the open infra space, in the OpenStack space, and in a broader open source space here at Canonical. So my name is Tytus Kurek. I am a product manager for OpenStack here at Canonical. And today I'm going to talk to you about cloud native computing. And we're going to dig in a little bit into this topic and take a while to celebrate this exciting moment in the history when the infra becomes an app. Yes, the infrastructure can be nothing else than an app. We'll talk about that in a second. So, oh, my slides are not moving for any reason. I'm sorry about that. Um, Not sure what's going on, Sharon, right? Like I try to move the slides and they're kind of not moving. Um, oh, yeah, it was there. I guess it's just coming with a significant delay. Yeah, so the future will be cloud native, right? Like I think it's clear for all of you, right? Like if you are at the university, if you are working for like a local or a global organization, if you're working in the app space, if you're reading through the internet, I think it's kind of clear these days that the future of applications is going to be cloud native. It's been concluded, right? Like everyone acknowledges that. No one's debating that. No one's questioning that these days, right? Like it's just concluded that the future is going to be cloud native. But at the same time, for all of you who have been working closely with technologies like Kubernetes, for example, um, it is clear that Kubernetes on its own does not address all the challenges. And this is because the Kubernetes itself is not capable of addressing all the challenges, right? Like it needs a whole supporting ecosystem around it. And there's way more technologies that we need to be able to build cloud native applications than just Kubernetes. And there are some technologies that were developed in the past that were very much popular at some point, but then they got abandoned in favor of solution like more modern solutions like Kubernetes, for example. I'll have to stop again. I'm really sorry. Those slides are not moving. I'll try to find another way to share my presentation. Um, I think this is the like I'll try to make it full screen. Okay, I'm really sorry about that. I think we found a way now. So yeah, Kubernetes does not solve all the issues, right? Like it does not solve it. It is a great technology. It serves as a foundation for building cloud native applications, but it does not address all of the issues that we are facing these days in the application space. And this is why I'm very much excited to see the latest announcement from the OpenInfra Foundation. So that it decided to join forces with the Linux Foundation to build a unified open source ecosystem, right? This movement, this change took us to a place where we have now created a united open source ecosystem of Kubernetes and all its surrounding technologies, as well as technologies that were created in the past that were very much popular in their own days. Technologies like OpenStack, for example, right? Like and the whole ecosystem around OpenStack, which is a solution that allows you to build your own cloud, right? Like if you think about all the leading public clouds like Amazon, Azure, Google, like OpenStack is something that allows you to build your own cloud. Like it resembles the behavior of leading public clouds. And it basically allows you to run it on-prem, right? Like in your own data center. It is like your own cloud that you build for yourself, that you build for your organization. And these two communities, the OpenStack community and the Kubernetes community, right? Like there was an unnecessary tension between them for a while. Right? Like both of them were trying to position their own solution as something that would be leading the future. I think that was unnecessary, right? Like, I think this whole tension was unnecessary. And what we've seen happening recently is a way better approach. It's right, like trying to unite those communities around a shared goal and around right, like a shared technology that could drive the future. Um, and if you think about that, if we stop for a second and try to understand what an open source infrastructure actually is underneath, it is nothing but an app. It is nothing but a software, right? Like OpenStack is just right, like a set of open source projects that allow you to drive the underlying infrastructure. They wrap around things like hypervisor. They wrap around things like software-defined networking. They can wrap around things like Ceph for storage. And as a result, right, like it is nothing but an app. It is nothing but a software. And every every app, every software can be made cloud native. Every software can be made cloud native. We know that because the official definition by CNCF, the Cloud Native Computing Foundation, well defines what are the building blocks for cloud native software. There is an official manifest by CNCF, right, like which exactly states how to build, right, like what are the building blocks, what are the principles for building cloud native applications. And those include things such as containers, service meshes, microservices, immutable infrastructure, and declarative APIs, right? So ideally, every cloud native software that you are building, right, like should align with right, like those five primary pillars. That, as you can spot, as you can see, right, like none of those definitions mention Kubernetes directly, and this is intentional, right? Because Kubernetes is just an implementation, right? Like what you see here is more like a technology, right? Like, so those are technological building blocks for cloud native software, while Kubernetes is just an implementation, right? Like it's just an example of an engine that can help you to build a cloud native software based on those principles, right? So if the infra is just an app, if the open source infrastructure is just a software, it also means it can be built based on those cloud native principles. And I'm going to show you how we think the future of cloud computing is going to look like. And this is what we can consider sort of a cloud native computing, is that It starts on top of any hardware, right? Like any hardware that has ever been created on the planet, either it's coming from like American manufacturers or like Chinese manufacturers or any other manufacturers. So it's like an open compute, right? Like should be able to cover that. Then obviously on top of that, we have the operating system that is capable of talking to this hardware and is capable of interacting with it. And now on top of that, we're going to have something that we consider a sort of a cloud native computing foundation, a cloud native computing foundation, right? So that will be your hypervisor. That will be your container runtime, and that will be everything that's eventually needed to be able to run a cloud native infrastructure and cloud native applications on top of it, right? Um, and as I said, right, like the open source infrastructure management platforms such as OpenStack are nothing but a software, meaning that they can also be distributed using cloud native principles underneath, right? Like they can be built on top of those like 5 primary pillars that I showed you on a previous slide, which are right, like a definition of cloud native by CNCF, right? So on top of this cloud native computing foundation, we can now put right, like a cloud native infrastructure management platform, right, like that would effectively be driving, right, like would be serving as an interface between the user and right, like this whole underlying hardware and right, like a physical infrastructure, right? um, and could serve as something that allows you to build and run cloud native applications on top of it, right? So given the future of computing is going to be cloud native, as we said, right, like we expect the majority of applications to be cloud native in the following years. But in fact, the reality is somewhere in between, right? Like in fact, we already have a lot of traditional applications that we have to deal with that are out there, right? Like those are the legacy monolithic applications that were built in the past, and over time they got virtualized. They usually run on top of VMware infrastructure these days, and this is also something that we have to deal with in our open source space, right? Like especially these days when we see a lot of organizations moving away from VMware due to very high licensing and subscription costs, right? Like and looking for a reasonable alternative in the open source space, right? So we need to make a space for both. We need to make a space for cloud native applications and traditional applications. That is something that the cloud native infrastructure can very much deal with. And effectively, this means this cloud native computing stack, right? Like this cloud native computing set of technologies can effectively allow us to run any software on top, any software, right? Like, and this includes the traditional software, right? Like those old monoliths that were built in the past that still run inside of VMs, as well as modern cloud native applications as we see them coming up more and more often. And this also means this stack allows us to run any software in terms of proprietary software. So like all of those Microsoft applications like Active Directories, Exchange servers, and so on, as well as open source software, right? So it can run anything. It can run on top of any hardware, and it can allow us to run any software on top of it, while we keep the stack itself, right? Like so, from the operating system through the cloud native computing foundation up to the cloud native infrastructure, fully open source. You might be wondering now, how does it actually relate with OpenStack? And this is when I'm going to introduce you to the project Sunbeam, which is something that we have been working on for years now at Canonical. This is something that has been officially moved under the governance of the OpenInfra Foundation 2 years ago. Uh, and that is something that is effectively serving as a foundation for cloud native infrastructure, right? So the project Sunbeam is something that we believe could serve as a foundation for like this cloud native infrastructure layer that you saw on the previous slide. And the project Sunbeam is based on OpenStack. And if you haven't heard about OpenStack, right, like this is the most popular open source cloud platform in the world, right? Like as I said as I said before, right, like this is something that allows you to build your own cloud, right? So your organization, your university, your company can be independent can become independent from, right, like the leading public cloud providers, right? OpenStack is fully open source, and it resembles the behavior of leading public clouds, right? So again, if your organization, your university, or your company is looking for a way to optimize the overall cost of running services in the cloud, right? Like this is something that can help because you can build your own cloud and get a better total cost of ownership, right? At the same time, right, like you can improve the level of sovereignty, right, like a digital sovereignty by making sure that you run your applications on top of the cloud that you own, and that you can ensure that you store data in a cloud that you own, right? Like instead of relying on, right, like an external provider to store your data and host your applications. Now, what makes Sunbeam different from any other OpenStacks out there is that we took a very careful approach when designing it to be able to address, right, like the 6 pain points, right, like the 6 challenges that over years we have seen in the OpenStack space being a real problem, right? And the first thing was the entry point. Everyone who has ever played with OpenStack knows that the entry point to OpenStack has been unnecessarily high. And when I first started playing with OpenStack, which was right like 11 years ago, it took me almost 3 months to get it up and running, right? Like OpenStack is just complex, right? Like and this complexity is there for a very good reason, right? Like at the end of the day, it is expected to serve as, right, like an infrastructure management platform for very complex environments, right? Like consisting of hundreds or thousands of nodes, right? Like very complex use cases such as telco NFV, such as high performance computing, right? Like such as AI, ML, right? And so its complexity needs to be there, but at the same time, it has kind of brought this entry point like unnecessarily high. So our goal when we're designing something was to lower the barrier to entry to OpenStack so that everyone could install it and everyone could operate it. At the same time, it comes with a human-friendly user and admin interface, enabling everyone with no previous experience with OpenStack to be able to get started with it, right? The operations aspect was also important for us to ensure that this tool would provide the same experience regardless of the scale. So starting from like whenever you are just experimenting with it, whenever you are just installing it for learning purposes or deploying a production cloud, like in your organization, like again, your company, your university, um, this should provide you with exactly the same user experience, right? Like, so what you learn when testing it, right? Like you should be able to use in production, right? Like exactly the same architecture, exactly the same set of artifacts. And addressing upgrades was another important challenge for us because everyone who's ever played with OpenStack knows that its upgrades tend to be very challenging. And this is again due to the overall complexity of the project, and so that OpenStack consists of multiple services that need to be interconnected to each other, that need to know how to talk to each other. Right, like there was right, like a set of dependencies between OpenStack services and the underlying OS. Right, like that was overall our goal to address it as a part of this solution. Um, Low footprint is another thing, right? Like this thing is now suitable for to run on devices with limited hardware resources, making it suitable for edge use cases, for example. Right? Like as we know, the edge infrastructure is expected to be bigger than public clouds in the following years, and improving the overall level of security by better isolation of OpenStack services. So this is what makes Sunbeam different from any other OpenStacks out there. And now if we stop for a second and try to uncover how this thing looks like underneath, how this thing looks like under the hood, there are three primary types of artifacts that we use to distribute OpenStack. Um, as a part of Sunbeam. And those are snaps, which are application container images that run directly on bare metal. Those are rocks, which are OCI compliant container images that run on top of Kubernetes. And those are charms, which are uh, operators, right? Like charms simply encapsulate operations code for applications. And now, um, if you recall the slide I was presenting previously with the cloud native computing stack, there was a sort of a mysterious cloud native computing foundation layer over there, which was not clear for us, for like what it actually represents. Remember, I had the operating system, the cloud native computing foundation, and cloud native infrastructure on top of that. And I told you it contains like the hypervisor, it contains like computer container runtimes and so on. Like, well, this is how this layer actually looks like in the canonical world, right? Like this is how this layer looks like in Sunbeam, right? Like so, it's based on like those four technologies. It's like snapd or like snapcraft, which is like a way of um, running application containers directly on top of metal, directly on top of hardware. It's Kubernetes, of course. There's like world's leading container orchestration platform. And it's Juju, which is the operator lifecycle manager, right? Like this is an engine that allows us to automate cloud native software delivery and cloud native software operations. So this these three technologies constitute right, like a sort of the cloud native computing foundation, right? Like as a part of the cloud native computing stack, right? Um, and now you can see on this slide how all of those things come together. So we obviously have Canonical Ubuntu at the bottom as the operating system. So this is something that helps us to talk to the underlying hardware. And we have like snapd, which is in the heart of everything.